Hi and welcome back to another LeetCode problem. We are having a look at a sliding window problem, LeetCode 76 minimum window substring. It's a hard problem. And I'm going to show you how to solve this and what the pattern for these sliding window problems is that you can always use, which makes it much easier to break down the problem. So let's have a look. So we're given two strings s and t of lengths m and n respectively. Return the minimum window substring of s such that every character in T, including duplicates, is included in the window. If there's no such substring, return the empty string. The test case will be generated such that the answer is unique. Now, so we can see here, M and S, they have their own lengths. We see that T might be longer than S, and everything only consists uppercase and lowercase English letters. Nice. So the challenge, well, one of the challenges of this problem is to really understand exactly what is being asked. So we are supposed to return a minimum window substring so that every character in T, including duplicate, is included in the window. That also means that if we have more characters in S than what is required in T, that could still be a valid substring. We just have to meet the minimum number of strings and their counts in our substring. So if we have a look here, you can see that, so we need to have the characters A, B, and C in our substring. So if we iterate over this string, so we're adding A, B, C, this is a valid substring, right, of length 6. However, there's also a shorter one, the B, A, and C of length 4. So what we will do is, when we do our sliding window, we will check, if it's a valid window, and then we'll just count how long, we'll just check how long the window is. And the big question is, when do we actually start to contract our window? Well, obviously, we're not going to contract as soon as we run into another A, because if we did that, we might be contracting too early. So what we will do is, let me see, only when we already have a valid substring can we start to contract the window. So that will be one of our checks that we will perform. So if we contain A, B, and C, and then we run into a B, right? That means we can now start to contract, but we can't, because if we remove the next character A, we won't have a valid substring anymore. So we need to be careful that we only contract A when we have a valid substring, and if contracting the window will not give us an invalid substring in the window. So those are the two key points that we need to take care of. Other than that, everything is going to be pretty normal. We're going to have a runtime that depends on the length of the strings in S and T, right? And they're named M and N time. And we're also going to need to store the frequency of the characters so that we can actually check of whether we match the frequency count. Otherwise, it's going to be a rather ugly comparison of our window every time with the string T, which we want to avoid. All right, and we're also going to need that in terms of space, because we're going to store the character frequency of T in a histogram, right? So our window will not be an array, it will be a histogram. And we will, before we do that, let's take care of some edge cases, so we know automatically that if the length of T is smaller than the length of S, I'm sorry, if it's the other way around, if the length of S is smaller than the length of T, it's impossible that S contains the same characters and counts of those in S. And the other case is if and or not T, so if T is an empty string, there's nothing to match. Well, in this case, we just return the empty string. Otherwise, we're going to prepare a result variable that we are going to return at the end. Now, let's build up our histogram. So we are going to iterate over all of the characters in T. And we're going to say if C not in hist, then we're just going to say histogram at C0, and otherwise hist at character C. Well, we're actually going to decrement it. So the histogram will contain the deficit count for every character. So when we iterate over our string S, we're going to increase the numbers. And when all of them are equal to 0 or larger, that means we have a valid substring window. So that's what we're going to do. Now the pattern. The pattern for the sliding window approach is always the same. It's always left, and then we have a right pointer, enumerate S. Now we're going to need to update window here by adding a new character, add C, and then we need to contract the window if the window is valid. Try to contract. And then finally update the result variable. So that is the pattern that you have in all sliding window approaches. Only contract when you know the window is valid, otherwise don't. And I would say we can already write the update function here because we know that we're going to store the result in here. We know that when we reach this point here, well, we need to check if valid window, right? That's a prerequisite. So maybe we should first think about what makes a valid window. Well, it's like I said. So if min-val in histogram is larger or equal to 0, that means it's a valid window. It's a valid substring. We don't know if it's a minimum substring, but it's a valid substring. And that is because we allow values larger than histogram to be in that window. So yeah, let's just put that here. So if result, well, if it's the empty, that means we didn't find a minimum one yet, right? In that case, we can say result is our string from left to the right, and then we have to add the offset. And the other case when we're going to update the result is if the length of the result is larger than the size of the current window, which is right minus left plus 1 as always, right? That is pretty much the update result part. Now, well, how do we update our window? Well, very simple. Just the same way we did here. We have to check if C in histogram. Then we're just going to increment that value, C plus equals 1. And that means we're going to ignore all characters that were not in T. Right? We allow non-T characters to be in our substring. And right. So that's what we do here. Now the next step is to contract the window. So the first thing we have to check if it's a valid window, right? So if min is larger or equal to 0, that's the first condition. It has to be a valid window. And the second one is, well, and by the way, this will always be a while loop, right? Because we might be contracting the window multiple steps, not just by one step. So if the minimum of histogram dot values, I almost overlooked that, dot values, right, is larger or equal to 0, we might be able to contract the window. And another prerequisite is and left is smaller or equal than right, because we don't want left to overtake right. But also, we now need to check, well, if we remove the next character, is that going to give us an invalid window? And the check for that is simply and histogram, well, and let's see, histogram at the next character, which would be string at the left position. If that is larger than 0, only then we can contract. But there's another edge case here. What if the character is not in our histogram? Well, this would give us an error, right? So what we can do is, well, it has to be in the histogram first, or like so. So if the character is not part of T that left is pointing to, then we can also safely contract the window without making it invalid. And the other case is that the character count for that character is larger than 0, which means subtracting 1 still leaves us with a valid window. So we'll have a left pointer increment here, and then we will do the check if sleft in histogram, then we're going to update our histogram at position at s left minus equals 1. Right. Yes, we could simplify that this expression, but we don't really need to. So I'm just going to leave this. So the pattern is update result if valid window contract window if window is valid and will remain valid. That's a better way to put it. Add to window. And this up here is just initialization of the window. Init window. Right. So that's kind of the pattern you see with these sliding window approaches. And the difficulty is just to figure out, okay, what does my window look like? So if you look at the different sliding window problems, you will find that if it's hard or medium or easy, it really depends just on the complexity of managing that window. And here we have a bunch of conditional statements that coordinate when to contract the window, which I guess is what makes this a hard problem. So let's run this through a test, see if that works. Key error D. Oh yeah, so I'm sorry, yeah, so wait, what do I have to do? Key error. Oh, this is a logic error. So if the character is not part of our histogram, it's not in T, then we can contract. So I had to fix that one. Okay, so now it passes the test cases, and let's submit it to see if it passes all of the tests. And it does. So yeah, so there you go. That was a sliding window problem, and yeah, just be very careful with how you manage the window. That's the takeaway.